Okay, so here this is the network we have already drawn in last class. Um, these squares are decision nodes, these squares and these numbered squares are decision node, and these circles are event node. An event node consists of probabilities, and our job is now fold back or analyze the problem. So we will start from the most right. We can start from either D or E. So let us start with from the top. We will first find out the EMV of node D. Let us start with D. EMV of node D. That you can get from multiplying the probability with the associated payoff. So if he sells C, then he get 2050, which is having probability 0.5. So, and if he cannot sell, that is also probability 0.5 and payoff becomes 0. So this becomes 0.5 into 2050 plus 0 becomes 1025. Now EMP of node E, EMP of node E is equal to 0.6 into payoff 1025 plus 0.4 into 0, which gives us 615. Next, we move more left. EMV of node 3. EMV of node 3 will be, if he takes C, there is no cost associated, no payoff. So that means EMV of node 3 will be having the maximum of 2, maximum of, there are two options. EMV of node D is 1025 and 0, which gives 1025. Did you got my point? Come at node number 3. If you look at node number 3, you will find that one branch says back out, do not go for C. Then he will get payoff 0. If he take C, then his payoff is 1025. And as because it is a decision node and there is no probability, it's his choice. If he chooses to take C, there is a profit or payoff of 1025. So the maximum between these two, 1025 and 0, maximum is 1025. That's why the node 3, at node 3, the EMV becomes 1025. Then again, we find out EMV of node 4. Similarly, if he backs out and does not sell B, then he gets 0. And if he takes B, then he get 615, which is EMB of node E. So he will choose maximum of, the EMB of node 4 will be maximum of 615 and 0, which is actually 615. Then we go more left, EMB of node B. EMB of node B will be 0.6 into his payoff 1025 plus EMB of node 3. EMB of node 3 is again 1025 plus 0.4 into does not sell payoff 0. And as a result, the EMB of node B becomes 1230. In previous problem we were looking for cost, that's why we are minimizing it. Now we are looking for payoff, that's why we are maximizing it. We are taking the maximum. Now at B, look very carefully at B. When we are calculating EMV of node B, there are two chances. 0.6 he can sell B. If he sells B, then his profit 1025, and because of the next step, because of selling C, he is getting his payoff again 1025. So that's why this 1025 plus 1025 together having a chance 0.6, and does not sell B, then the payoff is 0 and the tree ends there. So 0.4 into 0, so it gives you 1230. MV of node C, in this case it is similar with node B. So can anyone tell me what will be the EMV of node C?
So 0.5
0.5
in brackets 2050 plus 615
2050 plus
2050
615. Very good, very good. Next,
615
yeah, then
plus 0
plus 0.5
plus
into 0. Yeah,
0.5 into 0.
yeah, yeah, right. Very good, very good, very good. So then MV of node C, on upon calculating, we get this. Now we go further to find out, we go further left to find out EMP of node 2. EMP of node 2. Now EMP of node 2, there are three branches. One he takes B, second he takes C, third backs out. Can you tell me what happened here?
Maximum of BC
Maximum of,
0.
please
12
tell me the values.
I mean BC and 0. 1230
Node B
1230.
1230.
Maximum of node B, node C and
Maximum of node B 1230, C
1332.50
1332.50 and 0. So it will be
0.
1332.50. Okay, very good. Then we go furthermore left, EMB of node A. This will be 0.7 into, tell me,
200 plus
200 plus 1332.50
Sir, 1350.
plus
Yes, sir.
0.3
Yes.
into 0.
0.
That will give you 1072.75, and EMV of node 1 will be just, there is only one option, 1072.75. So the question was, drop an appropriate decision tree for the real estate agent. We have done that in previous class. What is the agent's best strategy under EMB approach? So his strategy is to find out maxed profit fast. So that means he will choose the path through which he can achieve his profits more. So if he takes this path which is I am showing in double line. So he accepts A, then he sells A, then you see upon B and C his max payoff is on C. It is 1332.50 and node B it is 1230. So he must choose to take C first, then he sells C, and then uh, he follows this path, then he takes B and he sells it. So this double line path will be showing the strategy of the real estate agents. So the path, the strategy will write the answer. The agent first sell A, then choose to sell C, then sell B. In this way, he can achieve his maximum profit looking at the probabilities. Any question on this problem? No questions. Okay. So I think you can understand we have completed two different problems, one with payoffs, second with costs. Okay. So you can understand you have to go through more problems and in a chapter. Now we cannot complete more than two. If we complete the syllabus and then if we have time, then we will come back here and we will solve few more problems. In the meantime, your job is to get any book, and Icarus already sent you book. So go through different problems, solve examples, then go to your exercise and try to solve few problems by yourself. Now then we will continue to our next chapter. This is today's job, 27/8/2020. Now we'll continue to our next chapter. And which is networks. Now this this chapter basically is a technique, networking and scheduling. This technique is used for planning and scheduling large projects in field of construction, maintenance, fabrication, okay, purchasing of new systems. Okay, so this is a basically a technique. We learn a technique by which we use it to plan and schedule our projects. Now the question comes, what is a project? A project is defined as a combination of interrelated activities and which must be accomplished in a certain order, and it consumes time and resources. So there are several activities which, when performed sequentially and all together, it becomes a project. So this work in a project can be subdivided in three ways. First is planning. Planning includes identifying the activities and acquire data to find out certain time required for each activity. Scheduling means and also find out orders or sequence to complete those activities. Now scheduling means a proper schedule exactly when an activity may started, when it will end, and how much it can be delayed, how much maximum it can be delayed without delaying the whole project, and how much time, how much maximum time or how much minimum time, actually how much minimum time requires to complete the project. That part is scheduling. Now these two, this planning and scheduling can be done in paper, and the controlling portion is actually the physical work. Controlling has again several phases. Controlling means to look after an ongoing project, and depending on the parameters, depending on several parameters, if any changes is required, then the the respective engineer have to make room for that. So that is controlling. Controlling includes, I'm coming from the planning phase again. The planning involves setting the objectives of the projects as well as if assumptions to be made, if any. Also, it also involves the listing of tasks or jobs or activities that must be performed in order to complete a project under consideration. Now, in this phase, some cost estimation and duration of various activities and the manpower, machines, materials, resources if required, the these are also to be determined in planning phase. In scheduling phase, the start and finish time for each activity, the critical path on which the activities require special attention. So if any activity on critical path if delayed, then the whole project will delay. So this requires special attention, and the slack and float for non-critical paths. That means how much it can be, kept uh, forward or kept backward. That means if we need to complete a job few days uh, ago, if there is any room, or if few days later if there is any room to find that out. So then it comes controlling. Controlling means making periodical progress reports, reviewing the progress, analyzing the status of the project, and making management decisions regarding updating, crashing, resource allocation, etc. So there are two ways we can analyze. Number one is CPM, critical path method. Number two is PART, or program evaluation and review technique. Now the CPM is used when the certain time frame for each and every activity is known. Then we go for CPM when the exact time for accomplishing a particular activity, all the activities unknown. Then we go for CPM. And if uh, we exactly do not know that how much time required for a activity or for any activity, then we go for part. So part is basically probabilistic, like you are putting a new product in market, or you are inventing something, you are trying to research out something. In such case, there is a probability that you can complete a project, you can complete an activity on say 10 days, but you are not sure about it. It might be 9 days, it might be 8 days, it might be 14 days. Okay, there is no surety that you will complete it by 10 days. So in such case, we use part. And when we exactly know that to complete an activity, we have a certain day when we certainly know that this activity can be completed on this particular day. In such case, we go for CPM method. Now, then what is the network? From this portion, I'm saying out the theories. These theories can be come in exam for 2-3 marks questions. Sorry. So then what is a network? Give me a minute. Okay. So network is basically a graphical representation of logically and sequentially activities and events in a project. So looking at the network, we can find out what are the what are the uh, you know activities associated with it, what are the events associated with it, and what is their proper sequence and how much time each activity can take. These all are cleared in the network, and this is also called arrow diagram. Now, the network is made of activities. Activity represents some action, some works, and it consumes time and money and effort. So this is a part of a project, and each activity has a point where it starts, where it ends, and it is represented by an arrow. This arrow is called activity, and it starts from an event which is denoted by I and which is called predecessing event, and this one is called head event and this is called tail event. So head number is always more than the tail number. These circles are called events. These events are points of time. This does not consumes neither time nor resources. These are just point of time. So this time I, we will call the event has been completed, and then a activity started. When a ended, event 2 started. So these two events are connected by activity A, where these two will be called head event or succeeding event, and one will be called tail event or predecessing event or preceding event. Okay, now there are different type of events. When more than one number of events are connecting in a single event, then it will be called merge event. And when more than one event coming out from a particular event, more than one activity coming out from an event, then it will be called burst event. Now preceding means जो पीछे वाला है, सक्सेडिंग मीन्स जो सामने है, एंड कंकरेंट मीन्स जो एक साथ हो रहा है. ये जो तीनों एक्टिविटीज है, इसको हम ए बोले, इसको बी बोले, इसको सी बोले, ये ए बी सी तीनों एक साथ हो रहा है, देन दे विल बी कॉल्ड concurrent activities. So here A, B, C, these three are concurrent activities. And here this is called preceding event, this is called succeeding event. Okay, now we need to know a term which is called dummy activity. This does not consume any time or resource. These are used when extremely necessary, and these are used to connect two events or two part of a project to provide logic in the project. Okay, this just his functions of these dummy activities are to maintain proper logic in the network and to maintain uniqueness in numbering system, as every activity has a distinct set of events by which the activity can be identified. So if there is any problem in numbering, then this dummy activity can be introduced. And there are some errors which maybe eventually occurs, common errors. One is looping. So there are some cases, is this type of cases.
Sir, right side portion not visible, sir.
Okay, got it.
Thank you, sir.
Thank you for bringing this into my notice. This is C, this is D. Okay, so if you look at it, you find the problem occurs, it is forming a loop, and this looping or cycling is not allowed in a network diagram. This is a very common error. There is another error which is called dangling. When you are making a network, you need to keep it in mind. So in such case, if you see this activity coming out and going nowhere, though it is not the last or the no, or the terminal event, still there is a activity coming out of the network and it goes nowhere. If we name them A, B, C, D, E, F, this D activity is going nowhere. So to disconnect an activity before the completion of all activities in a network diagram is known as dangling. So this problem is called dangling. So you need to make sure this doesn't happen. Okay, now there is another one which is called redundancy. Sorry. I have received a phone call and the phone, fall down.
सर डैंगलिंग की सर एरर नेटवर्क मध्य
Dangling error. Okay. Now we go for redundancy. These are all errors: looping, cycling, dangling, redundancy. When there are two parts of network and these two parts are connected only by a dummy activity. These dummy activities are shown as dotted lines of the arrow. So there is only one dummy activity between two parts of the project. This is called redundancy, and this is not allowed. Now we have some certain rules on network constructions. These are to be followed. Now what we have to do: first, avoid arrows that crosses each other. Number two, use straight arrows only, no curved arrows, only straight arrows. Number three, no event can occur until every activity preceding has been completed. पीछे जो हो रहा था वो खत्म होने से पहले कोई आगे वाला एक्टिविटी स्टार्ट नहीं हो पाएगा. An event cannot occur twice. That means no looping or cycling is allowed. Number 5, and succeeding activity, any succeeding activity cannot be allowed until the current or the present ongoing activity is completed. Okay. Next is number 6. Arrows to be used only left to right and do not mix two directions. Verticals and standing arrows may be used if necessary. Vertical arrows to be used if necessary, but no backward arrow is allowed. Dummies to be used if extremely necessary. Using of dummy is very rare. And the last one, the network has only one start event and only one end or terminal event. These are the rules, and when you uh, say out the rules, after that you need to number them. When you are constructing the network, you need a proper numbering system by which you number all your activities and events. So that numbering has a particular rule. This numbering has the rule which is called Fulkerson's rule. This rule says the event numbers should be unique. You cannot repeat a number, and the numbering carried out in a sequential manner from left to right. When you're constructing a network, you need to keep all in mind. Number 3, the event having only outgoing arrow will be numbered as 1, and later on we will continue. Now, at any point in the network in between, the procedure is delete all the arrows emerging from all numbered events. This will create at least one new start event. Out of all preceding event. Number 5, number all new starts. What we are getting in the last line, number all these new starts as 2, 3, and so on. Now repeat this process until the terminal event is reached, and then number the terminal event suitably. Now the head event of an activity should have higher number than tail event. Say call it 6. So you have to take care of all these rules when you are constructing a network. Now we have very less time less today, so we will end up here for today.